Yes, I'm Joe, and I'm working in the company Sparnex for a long time already. And Sparnex was the first to develop a copper-based chipset for what became later on the DSL chipset. We do that together because with Philipp Rietzch, who is an expert in fiber, and we just give an update on what's going on in copper and what is possible today. People think copper may be buried, but it's definitely not dead. Huh? There is still a lot of copper around, and people are asking for solutions. And that's what we are doing. We listen to what the customer needs, and if it's available, we will make a product. If not, we will design it. And so we are in a period of time where a lot of requirements come in, and there is not market enough to design it for the large companies. So we are a rather small company, but focused on copper. And we will give you an update on existing products today, what is possible, but also about some items that are important and that are new, in fact, in access network. We talk access network. What Philip will do is talking about fiber to the home, which is not access anymore. That's the first point, is where is the access ending and where is the demarcation point? And that is an important discussion because since you move into the building, you also move in private homes and in the places where you can't do what you ought to do. And that makes it more difficult to find the right solution for a home network. So together we are 80 years of experience, and we look into the reason why we would further develop in copper. What is the rationale? Huh? And if you look into what's happening, people talk a lot about the fiber, of course, because it is the technology that is today the point of development, the discussions in the engineering rooms. But there are a lot of copper out there, more than 1 billion today, still in the market. And these people still need solutions. And the fiber will not be the solution in the short term. In the long run, probably yes, but not in the short term. So you cannot guarantee the fiber bandwidth to everybody, but you can improve the copper-based transmission systems, improving up to 1-2 gigabit, no problem. But even today, we run systems and trials up to 8 gigabit over copper. Of course, the distance reach is less. We have not the same span as we had before with DSL, what is it, VDSL or ADSL. But since the fiber and the vibration of the network comes closer to the home, you can live with less speed and eventually also less distance. So the fixed lines are point-to-point lines. We do have also the coaxial network. Our colleague Helge will talk you after this session, will talk you about the coaxial situation. It is a very important evolution, because you cannot solve everything with wireless. You still need for wireless a backbone, and this all takes time. And you want to connect the customer now, the soonest. You want to make profit, and that is something which sometimes is not possible with the available technologies today. So how copper coax complements with fiber? The complementing is a big word, but in fact, your copper network is an already paid infrastructure. So you don't pay 1 penny to install the cable to connect to the user. And when you start to build a new network, there are limitations that are architectural, that are maybe not possible in a community, not permitted, whatever. So then the copper is, of course, your alternative. The ability also, that's something that only few people talk about, but Copper gives you the possibility to transmit power and to deliver power. That's not what you can do with fiber. So for certain cases, it is a limitation. And you also have the problem, of course, that you don't have the lifeline feature anymore. So if there is no power, there is also no connection any longer in fiber, which is still the case with copper. The fact that you can install immediately today when you have a request for a network and a customer is a very big argument for many operators. You see also more and more operators questioning if the fiber rollout should go that fast or should go the way it is today. Because it is a huge amount of money and investment, and not all operators have that money. The richer countries will be able to find the money for that, but there are many, many other countries which have not the funding. And even the rich countries, so to speak, have problems to find the funding. And they need to do things which is, in fact, limiting the rollout of the fiber. So that's an important thing, that this is with copper, you don't change anything. But what we say is don't remove it, keep it. Because removing copper means that you are, in fact, destructing an important network that you had already paid off, depreciated, and available in the market. So what happens among others in the DSL business or in the copper business is that we use in fact, we use the SFPs to build in the modems. You save the RG45 connection, you plug it in the router, and it works. You can do the same for end-to-end. What is the distance reached today? We talk about 0.4 millimeter cable, which is the Cat4, the worst case scenarios, where we reach 3 kilometers. This is not something you cannot connect with fiber. 3 kilometers for a downstream from 3 megabit and an upstream of 1.6. You say that's nothing. Well, if you have nothing, this is a lot. And thus the same if you go to 0.5 or 0.6 millimeter, you can go up to 4 kilometer, 4.4 kilometer, and 4.6 kilometer in the network. The point about, and I move a little bit faster because I still want to give my colleague some time, is that some applications I show you here, this is a first application where you can see that the fiber comes in. The fiber comes in, and then you just convert it into a coax link. The coax gives you, compared to fiber, about a factor 3.5 meter more longer distance. So it means if you have 100 meter over copper, you can do the same with the same distance, with the same speed over about 300 meters. The repeater is a very interesting product used by many, not in big volume, but the repeater is an no other choice product, which means that there is only one solution. And then it's not a question of cost or time. It's more a question to find the right solution. And if the repeater is installed, it is underground and it works. We have a reference of customers who is using it for 10 years in the ground. It works, okay? So looking into the repeater, that's one way to go. One moment, this one. So you have a fiber that connects to the DSLAM, and then you connect to the repeater, which is then giving you a double distance over with the same speed, or a double speed over the same distance. Okay, then this is a long-reach Ethernet, very popular in datacom environment, where the ITU-T is not so important. The interoperability is not so important, but it's important to reach a long distance for your datacom networks. And so you can use this technology. In many private organizations, this is a popular product. This is another product where you have an G.mgfast technology or a VDSL, with bonding. We know bonding what it is. Bonding is absolutely a very popular technology as well. And then this is an important one because it also do the repeater for G.mgfast running up to 8 gigabits per second. This is a very practical problem. By the way, we also had a poll in Broadband Forum beginning of the year. There were 11 service operators participating in that poll. And the result was that at least 70% think that the copper technology will help fiber in the future. And another 25% was not seeing the technology as a complement of fiber. They were just looking to it as a solution in their network. So this is the kind of technology that is possible here with the repeater and also the VDSL G.fast over twisted pair. You can also have, of course, the G.mgfast in double and then the remote power, which is for free. We have it, we can just deliver over the cable. This can be delivered to the customer. This is an important one because here you can see that fiber is at both ends. And this is also how I would like to present Peter here, because fiber can be extended and up to into the home thanks to the copper, because we use the copper to bring the fiber in the home. And that is also the point of the common point of interest with Teleconnect, which is a company specialized in fiber. I look to the time. It's okay. So the one thing I still want, two things want to say is the access network, distributed network. I was starting with that. It's unclear where the access network terminates, and that's an open point for the years to come. I think that the presentations are distributed later on. Okay, and the second thing is not so. It's an important thing, because the network has two phases. The phase toward the access, toward the operator, and the phase towards the application. If you put that in one box, you always have a frozen solution. What we see in a number of operators is they split it. They say we have a two-box approach. We have a termination of the access network, and we have an application, which is an whatever modem. It's not a modem, it's more a router alike, with all the features that are sold to the customer. This dual approach, this two-box approach, is one we see as very favorite for people who are not sure about the next generation of access network in their own network. They don't know yet how it's going to be. And then you can keep the in-house technology, the product, and just change the part for the access network. I give the word to Philipp, who will talk to you about the fiber into the home, especially the situation in Europe.
Yeah, thank you very much, Joe, also for the introduction. So basically, when we're talking about fiber to the room, all these schemes are basically led by the requirement, as we perceive that the end user requirements for their end devices is basically Wi-Fi. And the topic here is how to distribute Wi-Fi to every corner of the flat, of the house, of the structure. And this is not only for private households, but also maybe for professional households, for wherever you need to have some infrastructure to provide those. When we see for a typical FTTH deployment, we typically come in with a fiber. We have the ONU somewhere in the entrance of the building or of the flat. Then in the ideal case, we have some Wi-Fi access point directly built in or even set up a little bit, connected by Ethernet. But this is typically the majority of the installations. And this means that you have a less than optimal experience for the end user, because with a limited Wi-Fi availability, this basically limits the achievable speeds that the end user really experiences in their hand device that is really there. To overcome this, several approaches are possible. So, for example, to deploy Ethernet inside the flat and basically have multiple Wi-Fi access points, to have technologies like power line communication as a backbone, or as we propose it now, to look deeper into this, to install fiber to the room and to basically extend the fiber network also inside the house and inside the home as a backbone for basically Wi-Fi backhauling. There are several FTTR technologies in the field and available, coming from active AON-based technologies. We typically have now the big players G.fast based on PON technology, and basically so point to multipoint, and also other technologies like G.P2PF and technologies based on G.hn. And for example, in those days used reflector splitters, also called home PON in those days. And also there's a roadmap for further developments, FTTR 2.0. G.fin is basically, you can call it XPON cascading. So this means that you typically have the GPON or XGS-PON network coming from the access network, more or less simply replicated inside the home. And so you have one OLT structure placed back to back. Or if you look this in a different way, pointer somewhere. As you can even replace this OLT structure called with an SFU, and the ONT then becomes the MFU, and the ONT becomes the SFU. But actually, it's more or less the same structure, and the reason this is not really optimal in our extent is that it's really using transmissive splitters as for the FTTH backbone. So that's not really optimal for peer-to-peer traffic inside the FTTR network. When we're looking into those structures, I need to hurry up a little bit. With an all-optical network example, we're coming in from the FTTH network, all optical to the MFU, then in the in-building or in-flat fiber distribution network, attaching the SFUs, and then basically the SFUs typically have directly, for example, integrated Wi-Fi access points, and the end-user devices attached. This is in conjunction with what we just learned from Joe, basically possible, but neglecting a little bit that the access technology could also be based still on copper or other technologies. And looking at this for a non-all-optical network example, it's also possible to use G.fin for those. The main difference is here that we have, as I try to explain, more or less generic access network access. And so this can be DSL, this can be copper, this can be even, I don't know, satellite network, I don't know, anything. So it's not limited to fiber access. So, but at the looking at the in-home networks is still the same structure. Another possibility to integrate those is to use P2PF. That's a point-to-point fiber approch. This is basically not utilizing any passive optical splitters, as we see here for this picture, or as shown in this picture here, for example. And this is also one possibility. And this can also be used as an, basically directly integrated in the residential gateway, or also as an additional device to be set up behind this. As a technical comparison in terms of cost-wise, there are some sources that show this comparison here, where we basically see that the hardware cost is over all the flavors more or less is a factor, but it really comes to the labor cost and the passive component costs that we need to have in comparison with a classic Wi-Fi to the room architecture. So basically any cable that you put inside the household or any backbone that you install raises additional cost. And over this, you can compare different technologies with each other. Another possibility to implement fiber to the room is based on G.hn, which is shown here as an Etsy work at 82 from 2018, called HomePon also in those days. But the idea behind those is that in G.fin you typically have transmissive optical splitters. This means the peers are not able to optically directly communicate with each other. As per the access network, where this is mandatory. Here in GHN-based FTTR systems, we can use reflective splitters, where we can have peer-to-peer traffic directly from the end device to the other end device, which is quite beneficial when we're looking at home networks, where not every traffic is necessarily centralized as a data path. So this means that these activities here are almost 7 years old here. So this is quite some established technology. And based on HomePon, as I tried to explain, the structure looks like this. We don't have this transmissive splitter where we have 1 to n, but we have, let's say, an n to n star coupler, which is simply, let's say, a flock of molded glass where we have each port can optically communicate with each other port. Of course, you need to have a Bose operation on this. But this gives, in our experience, quite a big benefit in terms of installation ease, future proofness, and also, let's say, user experience to this extent. All those technologies are not really coming out of thin air. So this is already in development for quite some time in ITU and Etsy and IEEE. So this means based on GHN, there are activities taking place, and also based on GPON and PTPF. So this was basically what I would like to tell you. So I'm a little bit fast now. Sorry about this. Yeah.
Thanks a lot, Philipp. Interesting presentation. My quick question would be actually, why not going into the house with fiber and then doing everything with Wi-Fi, the fiber to the room? What is the advantage there? Can you explain that a little bit?
The advantage of fiber to the room over Wi-Fi. Yeah. Okay. In our experience, Wi-Fi is basically limited by, let's say, transmission distance and limited performance there. It doesn't really help if you have a high-speed access network with some Wi-Fi access point somewhere in the floor, and you only have the high performance in a 1 meter diameter from this Wi-Fi access point. So you want to have this spread over the entire house, including the garden and everything. So at the end, you need some sort of backbone network still to provide a good Wi-Fi coverage. And this is quite coming, this is standard like in, let's say, professional installations where you always have multiple access points that are coordinated. And this scheme is more and more tripping also inside home applications. And to utilize those, you really need some sort of high performance backbone network also inside the home. And this is our proposal to use FTTR for this.
Okay, I see. Okay, any questions from the floor?
Is that customer that's paying for the fiber to the room, or is it a solution provided by the ISP?
Yeah, that's really an interesting question. So one of the discussion points are currently where is as Joe already indicated, where is the network really ending? In Germany, we have different network levels. So we have network level 5, which is the in-home network. We have network level 4, which is more or less house and access, and so on. Network level 3 going down. And typically, I would say it depends. From my experience, this is now more or less private activity, what the people have inside their home. So typically the network ends at the demarcation device, and everything's coming afterwards is up to the customer. But it's not necessarily the way. As we also learn from the other speech about the management stacks going further, there might be some interesting perspective for the future. also to monetize this. Yeah. of
Thank
course,
you.
yeah.
Okay, any other questions? Looks like we're there. Hey, thanks a lot to Joe and to Philip. Excellent. And again,